All right, so first geometry concept from 10th grade I got to review with you is Pythagorean Theorem. So make sure you're on day 3.6. Day 3.6. I'm probably going to go fly through this a little bit because a lot of you I know have already been exposed a lot in your high school career to Pythagorean Theorem. You got to have a right triangle, first of all. All right, got to have a right triangle. You got two sides of the triangle that are called legs, which we usually have A and B on. And then you got your longest side, which is called the hypotenuse, which we usually call C. And then Pythagorean theorem is A squared plus B squared equals your C squared. All right, I know we're very familiar with that, so let's use it in a couple problems. So choice A. Problem A here. Draw yourself a right triangle, ABC. I tell you where the right angle is. It's at C, so put C at the right angle. All right, so I have AB. We got AC is 2, BC is 3. What's AB in simplest radical form? All right, so I have a right triangle. I know something about all three sides. I'm going to use Pythagorean theorem, and now I'm going to ask one of you guys to go ahead and plug in the values for me. Here we go. Let's get this started. Colin, go ahead. What do you want to plug in for A, B, and C here?
For A2 plus 3, and then you have C.
C squared, X squared, doesn't matter. Make sure we're squaring those numbers we're plugging in. And then we keep going here. I got 4 plus 9 equals C squared. C squared equals 13. Real quickly, I still have C squared, but I need C by itself. So what do I need to do on both sides here? So quick review. Here we go. Liz, what do I have to do on both sides to get that C by itself?
Square root.
Good job. Take the square root. And guys, just get in this habit that sometimes you can't just go to your calculator, do the square root of 13 and write down that decimal. The directions are going to be a little bit different from time to time. Take a look at these. Simplest radical form. So you need to break that radical down as far as it could go. So let's review real quick on how I break down a radical. All right, because I'm sure it's been a while since we've broken down one. So I have the square root of 13. First thing you need to check is there a perfect square that goes into 13 evenly? And what do I mean by perfect squares? Grab your calculator, everybody. If you don't know what a perfect square is off the top of your head, grab your calculator. Go to y equals like you're about to graph something. All right, go to y equals like you're about to graph something. And type in x squared in your y1. X squared into y1. Now go, you remember how to get to your table of values? Second graph. And now everyone look at your y column. Hopefully it matches mine up on your screen. Those are all perfect squares. Those are all perfect squares. So do any of those go into 13 evenly? Any of those go into 13 evenly? Absolutely not. So that's as far as it can be broken down. Square root of 13. If we come to a problem where a perfect square does go into it, I'll address it. All right, but no perfect square goes into 13, so we're good. All right, let's keep moving. Any questions? I don't want to go too fast because I got to save time for the second half of today's notes. All right, how about Laura? She's a gardener. Isn't that cute? She's a gardener. Anybody else a gardener in here in this class? Do I have any gardeners in here? I don't want to offend anybody. All right, her garden's 12 by 15 feet. And she wants to put a little rock walkway on the diagonal. Wow, really fancying it up, huh? Diagonal, guys, corner to corner, right? Diagonal, corner to corner. She wants to put a rocks there. You can draw your own rocks if you want. How long is that walkway? I should have put the walkway the other way. There we go. How long is that walkway? All right, well, if you don't remember your geometry days, rectangles have right angles, so that's how I know I'm dealing with a right triangle. So again, I know something about all three sides, little Pythag in my life, nothing wrong with that. All right, could somebody fill in for the values for me? Here we go. Bassett, go ahead. What do you want me to plug in for A and B and C?
12 squared plus 15 squared is equal to C squared.
Got it, boss. Thank you. Great job. Now I just go to my calculator. You guys can figure out 12 squared plus 15 squared. So I got 144 plus 225 equals C squared. What did I end up? I closed my 369. And Liz told us in problem number 1, you got to take the square root of both sides. Now, I said from problem to problem, the directions may change. They don't ask us to leave our radical in simplest radical form. It says leave it nearest tenth of a foot. So now I can go to my calculator and take the square root of 369 and see what it gives me and round it. When you get the rounded version, let me know. Colin, back up to you. What's your rounded version here to the nearest 10?
1 second. I'm using
Go ahead. Go ahead.
Shoot. Alright.
A lot of clicking there.
19.2.
Got it. 19.2 feet. All good, guys? Okay. Those two I consider basically ones you probably did in your geometry days a couple years ago. Now we have to do a Pythagorean Theorem one where it's at our level now, all right, in this class. Bring it up a couple notches. And that's this last one here, C. All right, this is where we got to be as far as Pythagorean Theorem goes. Doesn't look like much, right? It's just a right triangle. I know the sides. Hey, let's use Pythagorean Theorem. I just need somebody to plug in my A, B, and C value here for me before I get going with it. You're good, Colin. You're good. Here we go. What do we got here? Oh, Nick, son of a gun. Somebody else got to take over. Liz, go ahead. What's my A, B, and C value?
A, x minus 4.
Okay, so here you go, everyone. Take a look what I'm about to write before Liz gives me the rest. X minus 4, all squared. Plus, what's the other leg, Liz?
Is...
You got x minus 4. The other leg is?
8.
8 squared equals, what's my hypotenuse now, Liz?
X.
X squared. Good job. Yep, thank you. Okay, everyone good on the setup, what Liz just plugged in? All right, now be careful here. This is the part I worry about right here. This is why this is a challenge one. You just don't simply take the 2 and apply it to everything inside. That squared is telling you, hey, everybody, you need to multiply x minus 4 times itself. All right, twice. Multiply it by itself twice. So you're going to have to do a little double distribution right now off to the side. All right, keep that in mind. That x minus 4 all squared doesn't mean just take the 2 and put it inside. It means multiply it by itself twice. All right, so I'm hoping, make sure our work matches. If not, change it. You should be getting x squared. And then in the middle, what do you have? Minus 4x in the middle, right? Well, they don't cancel each other out. That becomes minus 8x. All right, minus 8x in the middle. Negative 4x minus 4x, negative 8x. And then negative 4 times negative 4 is positive 16. So that's what I get when I double distribute. Any questions? Open it up here. Don't be ashamed. And then 8 squared is 64 equals x squared. Everyone all right where we are? This is why this is at our level. The algebra is pretty hardcore here. Okay, can you guys clean up the left side for me? Clean up that left side because there are two terms you can combine there. X squared minus 8x. 16 plus 64, got an 80 there. Plus 80 equals x squared. Ooh, boy. Whew, you guys made it to this level for a reason. Any ideas what you want to do next here?
Factor.
That's what everyone says, Caroline. Because you see an x squared, right, Caroline? So you want to factor, right?
Yeah.
Everyone else, yeah, you see an x squared. Usually that means I factor. Yep. So here, I cannot factor unless one side is equal to 0, though. Remember, that's always my rule. I can't factor anything unless one side's equal to 0. So if go ahead. What's up, Caroline?
You can subtract x squared.
Okay, I can subtract x squared. But guys, what's going to happen when I do that? Go ahead, everybody. Subtract x squared. What's going to happen? Guys, what happened? See ya! They're gone. Right? They cancel each other out. So I'm left, and that's okay. That's going to happen. So now what am I left with? Negative 8x plus 80 equals, I'm left with a 0 over here now. No big deal. And that's actually good news. No factoring. That's good news. Now solve for x. Get x by itself for me now. The x squared's canceled. Get x by itself. Here we go. Eliana, how do you want to get the x by itself? You got a couple moves you can make.
I added 80, or subtracted 80.
Okay, that's fine. You can subtract 80. If anybody added 8x, that's fine too. Perfect. So I get negative 8x equals negative 80. Guys, divide both sides by negative 8. X is going to be equal to 10. All right? That's the Pythag level we're at. Questions from you guys? So there's Pythagorean Theorem, a little quick review of that. All right? All good? Questions? All right, now I'm going to warn everybody on this next section. We're only going to do parts A and B. I'm going to save C for another time. We're only going to do parts A and B so you guys can get practicing. What we're about to do in the next 10 minutes is probably what you spent probably 3 days in geometry covering, and I'm about to do it in 10 minutes. Maybe some of you didn't even do it in your geometry class, depending on the teacher. Okay? I apologize for that. I don't know what to tell you, but if you want me to go slower, tell me. Don't be ashamed to open up your mic and ask questions, okay? I'm the only one that cares what your question is, nobody else, trust me. All right, so don't feel uncomfortable because you're worried about what other people are thinking. Stop me, all right? Stop me, please. All right, so next up, 2 special types of right triangles. The first one we're going to talk about, the first type of right triangle, has 2 special degree measures in it, 30 and 60. We call it a 30, 60, 90 triangle. I don't know if anything rings a bell from that from a couple years ago, but that's your 30, 60, 90 triangle. Their sides have special relationships. All 3 sides are related somehow. Ready? Let me just cut off this right here. All right. I'm going to have you guys make a chart. A 30, 60, 90 chart. Okay? Which represent the degree measures. the side across from 30. The side across from the angle 30 degrees, I'm just going to call X right now, X. It has a relationship with the side across from 90. Ready? Listen to this carefully. The side across from 90 is always double the side across from 30. So I'm going to put a 2x here. All right? So just to show you with actual numbers, do not put this on your diagram. I don't want to get it even more confusing. Ready? Do not, just look at my diagram up on your screen. If I put a 6 across from the 30-degree angle, that automatically means the side across from 90 is 12. Everyone see that? Okay, that's their relationship. The side across from 90 is always double the 30 side. Again, if I put a 10 here, across from the 90 will be 20. All good? See that relationship? Now, what's the relationship with the side across from 60? That will be your 30 side times the square root of 3. And now I'm getting crazy, I know. Times the square root of 3. So what I have up here right now, you see my 10 and my 20? That means across from the 60 is going to be 10, the side across from 30, times radical 3. So that's what this relationship is right here. Here's an example with actual numbers. Any questions yet before we get to an example of it in part A? Okay, part A. Go ahead, draw yourself a right triangle. It tells you the right angles at C again. It does not matter where you put A and B, will not affect the problem, but C has to be where the right angle is. Angle A is 30, so inside angle A right here, everyone, make sure you put 30 degrees inside angle A. BC is 8. BC is 8. And find AB. So we need to find AB, the length of AB. All right, everyone ready? Take a deep breath. This is a 30, 60, 90 triangle. We all in agreement there. This is 30. If you want to fill in the other angle as 60, go right ahead. If it makes you feel warm inside, fine. This is a 30, 60, 90 triangle. So I get out the same chart that I had above. Across from the 30 is x, x radical 3, and 2x. Here's what I'm going to ask somebody. They gave us a side length of 8. What angle was the 8 across from? Look at your diagram. What angle was the 8 they gave me across from? Go ahead, Mason. What angle is the 8 across from?
Angle A.
Which is how many degrees?
30.
It's across from the 30-degree angle. Does everyone see that? 8 is across from the 30-degree angle, which is right here in my chart. So I'm going to put an 8 right underneath the 30. So what does that mean? It means x equals 8 in this problem. X equals 8. Can you fill in the rest of the chart with me now? If x equals 8, what's across from the 60 then? X radical 3. And what did we just say x was? 8, because it was across from the 30. So this is going to be 8 radical 3. And what about the side across from 90? Well, that's 2 times the x. So it would be 2 times 8, or double it, 16. So now we just got to figure out which one is my answer, 8 radical 3 or 16. Which one is my answer? Well, they wanted us to find AB. Look at your diagram, Look at AB. Look at your diagram, everybody. AB is across from what degree measure? Hunter, here you go. AB is across from what degree measure?
90.
90. What did we put in our chart across from 90? 16. All right. It's not too bad when they give you the side across from 30 to start out with. The chart's not too bad to fill in from there. It's when I'm given something else other than the 30. Guys got questions? We all right? Go ahead, ask away here before I get into the next one. Anything you want to ask? Because I got one more problem and then you got practice.
Are they always going to be 30, 60, 90?
No, they're not. I got one more to do, Isaiah.
Okay.
I got one more to do. There's one other special type other than 30. I wish it was just 30, 60, 90, but. Anybody else? Questions before I introduce the second type of triangle? Anybody remember the second type of triangle from your geometry days? 30, 60, 90, and anybody remember the other one? You want to show off some knowledge? Nobody remembers the other one from your. Go ahead, show off. Come on, somebody show off.
Is it 90, 45, 45?
Mason, my man, right there. Showing off from your geometry days. Who'd you have for geometry back in the day?
Oh, God. I had Miss Hines.
All right, good. We got something out of there. 45, 45, 90. I didn't have any of you guys in 10th grade, so. Nope. All right. So 45, 45, 90. They have special relationships. I'm also going to fill out a 45, 45, 90 chart here. This chart's actually easier to remember than 30, 60, 90. Because you got two 45s in there, right? The sides across from the 45s are always the same. The sides across from the 45s are always the same. So in the 45, 45, 90 chart, you're just going to put X and X underneath the 45s. Because those sides are always the same. Always the same length. Again, don't throw this on your diagram. I'll just put it in mine. So if this side is 6 right here, across from that 45, across from the other 45, always 6. Okay, they're always the same. What about the hypotenuse now? The side across from 90, ready? That's your X value multiplied by radical 2. Your X value multiplied by radical 2. So this here for me would be 6 radical 2. Okay, so that's what a 45, 45, 90 looks like. Any questions before we use it on part B? Oh, go. Anybody want to do a diagram for me here? Part B, a ladder leaning up against the wall at a 45-degree angle. Anybody going to make an actual ladder, or should we just make a right triangle and just call it a day? All right, here we go. Ladder's over, ladder, lean, here you go, drawing in the ladder. One more time. Drawing in the ladder right here, leaning up against my wall, makes a right angle, and a 45-degree angle with the wall. So 45, 45, 90, right? And the ladder is 12 feet. So there's 12 feet, the length of the ladder. How far up the wall does the ladder reach? So basically, what's the length of the wall here? How far up does it reach, right? All right, so let's see how our chart can help us now. Remember, it was X, X, X radical 2, right? We're trying to find one of the sides across from 45. So look, I got to find what's in here. That's what I need to know. What number belongs in there? I need the one side across from the 45. But what did they give me? 12. What angle is the 12 across from? What degree measure is the 12 across from? Woo! Go ahead, Colin. What degree measure is the 12 across from in this triangle?
90.
90, so it's got to go right there. So how do I go from here to there is the question, right? How do I go from that 12 to the side across from 45? Well, here you go. We're going to set up a little equation now. 12 is equal to what in my chart? What's above it? It's equal to x radical 2. And what value do we need in the chart? X. We need x here. That's going to be my final answer, whatever x is equal to. So how can I solve this for x? 12 equals x radical 2. How do I get the radical 2 out of there? Whew. Any thoughts? How do I get the radical 2 out of there? I don't want to call anybody on this one because I don't know how many of you know this.
You square it.
Close. All right, I don't want to because if, let me put it, how should I put, if I want to square it. Here you go. If I had this and I wanted to get the x by itself, then I would square it, yes. But I have something with it here. Here you go, guys. What is happening between the x and the radical 2 here? What operation is happening between x and radical 2?
Multiplication.
Thank you. So how do I undo multiplication?
You divide.
Divide it. So I'm going to divide by what?
No, I'm done.
Okay, thank you. You want to get x by itself, Caroline. So you want to divide both sides by radical 2. Because watch, see how those cancel now? And you're left with x equals 12 over radical 2. Everyone all right what I just did there? Because look in the parentheses in the directions. What's it say? Leave your answer in. Ooh, simplest radical form. Oh, boy. You guys remember anything from your, and just show off here. I don't care if you're right or wrong. Just show off. Anybody remember anything from the algebra days, either algebra 1 or algebra 2 last year, about having a radical in the denominator? Anything? Radical in the denominator?
Don't you multiply by radical 2 and radical 2?
You got it, Liz. Way to show off. But guys, you can't have a radical in the denominator. You cannot have a radical in the denominator. So to get rid of the radical in the denominator, you multiply top and bottom by that radical. You are not allowed to have a radical in the denominator. So to get rid of it, you multiply top and bottom by the radical. Some of you remember this. You just don't want to say it. All right, what am I left with on top? 12 times radical 2. Just put the 2 together. 12 radical 2. And then look what happens on the bottom now. Remember anything that happened with a radical times itself? I think you do. A radical times itself. No? Go ahead, on your calculator right now. Go ahead, everyone. Go. You find out yourself. Radical 2 times radical 2 in your calculator. And tell me what it comes out to be. Radical 2 times radical 2. Itself. It should be 2, right? So 2. So no more radical in the denominator. But anybody think we can go any further with what I've just written down? 12 radical 2 over 2.
Yes.
What is it then? What do you think you can go further with?
You divide and you get 6 radical 2.
There you go. I can divide 12 and 2 to finally get an answer of 6 radical 2. I know that was a lot, but again, here's where we got to start. 12 equals x radical 2 and go from there. And that's all I'm going to show you today. because I want you to practice this on your own. All right, it's just going to hurt if I keep going on. All right, so go ahead. You got an assessment, Delta Math 1. Let's get Delta Math open. You still got a solid about 10 minutes here, a little less. 3.6, everybody. Let's get it going. I'm going to make sure everyone's on Delta Math here in a second as I look at the browsing history. If there's something you can't answer after a couple tries, hey, Mr. Carlino, this is what the question says. Can you help me? All right, open up your mic, ask questions. No shame in that, especially this unit. It should be a combination of Pythagorean Theorem questions with the 30, 60, 90, and the 45, 45, 90 triangle.